Hi there, my name's Jeff. I work in the applications group here at Waterjet, and today we're in our new demo center. Proud to show this off. We'll be cutting on our X1530 machine, Apex 60 head on here for 5-axis cuts. We'll also have 2D heads. So we're going to be cutting some glass and stone today. These are materials that if you try to pierce them with high pressure, the materials are likely to shatter. So we'll show you some piercing techniques that can help on materials like this. This can also come in helpful on materials like fiberglass, any sort of material that's fragile. Hopefully the techniques that we show you today will help you out. So let's step into the programming.
First, we'll walk through how to program the part that we're going to cut out of glass. So I've got the WordCam package open. This will open up DXF or DWG files. So here's the part that we'll be cutting. I've also got this square around the part here, which represents the blank of glass that we'll be cutting this part out of. I've got a fixture on the table, and I'll be putting this blank into the fixture. And in the last step in the process, I'll set my 0, 0 point to be the lower left-hand corner of this piece of material. So top right-hand corner, we hit our next button. Top left here, we select the nozzle orifice combination that we're using, and the material, which will be glass, and thickness 3/4 inch. And if we want to drill down into the material, can go into the material database. On this feed rates tab, we've got our 5 different feed rates for 5 different quality levels, from slow and smooth to fast and rough. And then on the leads tab, we have information about length of lead ends, and up here we have this toggle button here to indicate to WordCam that we want to use circular pierces, and in conjunction with that we have the fragile toggle here, which will tell WordCam to put the pump into low pressure when we're doing the circular pierces. Do all the low pressure circular pierces first, and then the pump will go up into high pressure and pierce through those pilot holes that we've made. Down at the bottom, if I click on the advanced button here, on this other tab, we've got parameters that control time in seconds that we'll be doing the circular piercing, speed that we'll be doing the circular piercing at, and the diameter of the circular pierce. With that, in order for me to recognize this exterior rectangle for my blanket material, I'm just going to use this marking tool, and I'll remove that once I've got my toolpath on here. This will just give me a visual indicator in the next step of where my lead end is going to be for my outside of my part here. Top left hand corner, I can click on the auto button to put the toolpath on here. So we've got our blue lines, which are the rapids, and the red lines, which are the cutting. If we zoom in, you can see the circles at the end of the lead ends there, indicating that we're doing a circular pierce. And if you want, you can just click and change lead end position if you need to. WordCam does a nice job of collision avoidance, where it's always going to move away from where it finished cutting to avoid potentially crossing over where there might be a slug tipped up. And we can do things like change quality on holes. So right now all these red cuts are done with a mid-range or normal speed. If, say, for example, we wanted to do the entire part as slow and smooth, we can select all of our cuts here and change this to smoothest, and then the color changes. Can also do a similar thing for just one section of a cut with this partial qualities tool. You can expand this, and if there was an edge here where we want to cut a little bit faster because it wasn't going to be a visible edge, you can click 2 points and then left click and lock that in there. But since we are going to be doing this entire thing as smoothest, so it looks beautiful for our webinar, I'll put that back to where that was. The other thing we can do to make our life a little bit easier in a situation like this is, whenever you can, is pierce off the edge of the material, and then you can just do a high pressure pierce off the edge and not have to do another circular pierce. So right now it's got the circle on there. If I want to change that to be just a regular high pressure pierce, I can go into my edit leads button here and turn off the circular leads for inside outside, and click on save and exit, and then when I click, changes that to just be a regular high pressure pierce there off the edge of the glass. So we're gonna get rid of that marking because we don't need that, since we got our lead in on there and we can see that we are off the edge of the material. So we'll just remove that. And then top right hand corner, we can hit our next button, and on this last step here right now, our 0, 0 point is set at the lower left hand corner of the part. However, we are going to be cutting this out of a fixture, and since this corner down here represents the corner of the fixture that we want to put our 0 point on, we can hover over that corner and move our 0 point to the corner there. Now, top left hand corner, we can click on the CNC button and create our CNC file. So with that, let's go ahead and cut this.
This clip here, I just wanted to show you what happens if you do try to pierce glass at high pressure. So there's two key factors when you're piercing. You want to make sure that you're at low pressure, and you want to make sure that you have abrasive at your cutting head. And so in this little clip here, we'll do both of those things wrong. We've got our pump at high pressure, and we'll go ahead and just wrap it over and just hit this and see what happens. So there you go. We have successfully shattered our glass by piercing at high pressure. So hopefully now we can show you how to avoid that. In the lower portion of our pump here, we've got our electric motor, and then we've got our hydraulic pump here, and this creates our 3,000 psi of oil pressure, which is in turn converted to the 60,000 psi of water pressure. It's a variable displacement hydraulic pump, so there's a swash plate in there when you're at that full 3,000 psi of hydraulic pressure. That plate's fully tilted over, and then when the pump goes into low pressure, then that plate tilts more vertical, reducing the oil pressure and in turn giving you lower water pressure. Okay, we've got our piece of material for our final part here. Again, we've got a piece of underlay, a piece of Lexan. So we'll just put this into our fixture and clamp this down. So we'll go ahead and load our program. Start the program, confirm that we do have our abrasive in the low pressure setting, which we do, and run. And I'll go over and do with low pressure purge.
So for people that are doing a lot of low pressure, high pressure piercing, we recommend doing this purging procedure to bleed off the high pressure. There's basically two ways to bleed off the high pressure from your pump. It can either go through a bleed down valve on the pump. Can very quickly go from 60,000 psi, drops it down to basically 0 psi, and then builds the pressure back up to your low pressure, 10,000 psi in this case. It's a very rapid way of doing it, but there is going to be more wear and tear on the high pressure components. If you're only doing that a few times a day, that's not usually a big issue. But for people that are doing a lot of high pressure, low pressure piercing, that can add up and lead to fatigue of your high pressure components. So with this procedure, we bleed the pressure out through the cutting head, which is a much more gradual procedure and extends the life of your high pressure components. The other thing you'll notice here as we're doing our low pressure piercing is that we start moving the cutting head and then turn the water and abrasive on. So another key thing when you are piercing glass is you don't want to be stationary when the water and the abrasive turn on, so that's what we see going on here.
This is our smart meter mini hopper. We'll typically quote this when somebody's doing a lot of low and high pressure piercing for piercing, say, glass, for example. When the pump is in low pressure, we send a signal to that mini hopper, which has the wheels spin at a relatively low rate to let less abrasive down to the cutting head. And then when the pump goes up into high pressure, then the wheel will spin at a higher rate, letting more abrasive down to the cutting head. So if you're doing a lot of low and high pressure piercing for glass or composites, then this is a nice mini hopper option. looks like a nice piece. So with that, let's go ahead and try cutting some stone now.
We'll quickly program a part here for Granite. I'll just take a part out of our shape library. So I'll grab this one here, and we're going to make it a 5" by 5" square, 4 sides, 1" diameter hole in the middle there. Alright, top right hand corner, hit our next button. This time we're going to use our Apex 65 axis head with height setter and 1440 nozzle combination, and doing black granite, and it's 1¼ inch thick. So we'll hit our next button, click on the auto button to add our vertical cuts, and since I'm going to be starting my my bevel cut up here at this side, I'll move my lead in for this hole over to here, and I'll move my outside lead down to here since we'll be doing a bevel cut down there. And for the bevel cuts, we've got the bevel tool over here. You can choose top or bottom bevels, and then on this hole here we'll do a 45-degree countersink all the way around there on the top. So we'll do top bevel, hole contour. So activate that tool and then just click. So that blue line indicates where the cutting tip is going to go around that hole to give us countersink on there. And then if we just want to put a bevel on one edge, can turn off this hole contours button here, and then we'll left click and left click and left click to lock that in there. There's our bevel, top bevel cut on that side, and then on the we'll do a bottom bevel cut along this edge down here. So left click and left click and left click. There's that. So we've got our countersink. I usually like doing the vertical cuts first on those holes there. Hopefully that slug will drop out. And then we'll do the countersink, and then top bevel, bottom bevel, outside cut. Click on the next button. Click on CNC button. Give it our name. And now we're ready to go ahead and cut this.
Okay, let's go ahead and cut that granite. So I've got that clamped down right now, 1¼ inch thick, about 37 millimeters. We'll be using our Apex 65 axis head. It's capable of angles up to 60 degrees. So it's a nice application for cutting bevels and countertops and such. Let's zoom in and take a look at it. There we go. There's our nice little 5-axis part out of granite. Well, I hope you've enjoyed that. Hopefully you've learned some new techniques for piercing some fragile materials like glass and stone. So let's see what sort of questions we've got. Thanks for your time.